And welcome back again to my channel. So today we are going to start with the next topic, which is exploratory data analysis. So let's start. So exploratory data analysis, it is an essential step in data science which aims at examining and understanding data to uncover patterns, identify anomalies, and gather insights prior to formal modeling. So it lays the groundwork for hypothesis generation and selecting appropriate analysis or machine learning techniques. So in Python, this exploratory data analysis it involves the following steps. First is loading data, that is importing data from various sources like CSV file or from MS Excel or from the databases that we create using libraries such as pandas. And then descriptive statistics. So it is computing measures like mean, median, standard deviation, percentiles, and other summary statistics to understand central tendencies and variability. Then third is data visualization. So it aims at creating visualizations such as histograms, scatter plots, box plots, heat maps with libraries such as matplotlib, cpond, or plotly to identify trends, relationships, and outliers. Then handling missing values and outliers. So it is increasing missing data through techniques like imputation or removal and detecting outliers for further analysis or correction. Then we have feature analysis, which is investigation correlations, distributions, and interactions to determine the importance and relevance of variables. Then EDA, it ensures comprehensive understanding of data set, paving the way for reliable and accurate predictive modeling. Then we have that how to construct a bar graph with overlay. So to create a bar graph with an overlay, we can use Python to visualize categorical data with subcategories. Then we can also use matplotlib or cpond and we can overlay bar graph by specifying different categories or by plotting additional bars with adjusted positions. Like for example, we can import cpond as SNS, then we can import matplotlib.pyplot as PLD, then we can plot pandas as PD. Then we can enter our subdata value, which is category and then subcategory. Then then we can add df is equal to pd.dataframe, which is data. Then we can create a bar graph with an overlay. Then is sns.countplot, which is plt.title. Then plt.xlabel, then plt.ylabel, then plt.legend, which will be entered as a subcategory, then build.titleout, and then plt.show. So the key adjustments are improve data frame setup, then ensure the PD data frame is assigned as clear, then enhanced plot styling, which is added palette for better color differentiation. Then is detailed labeling, which is including access labels, a legend title and descriptive plot title for clarity. So this approach helps clearly visualize the count for each category broken down by subcategories. Then how to construct contingency tables. So contingency tables are also known as cross tabulations, which show the frequency distribution of two or more categorical variables, which makes it easy to observe the relationship between them. Then we can use pandas.crosstab to build contingency tables with two or more categorical variables. Then we can import pandas as PD, then we can enter the subdata, which is category and subcategory. Then we can enter df, which is pd.dataframe, and we can fetch the data, then contingency table, and then display that table. So the key adjustments are improved readability and formatted output, that is index and columns are clarified more and we have added a label for printed output. Then this script of that table, it summarizes the relationship between category and subcategory by showing their joint frequency distribution. Then how to construct histograms with overlay. Constructing histograms with overlay, it enables comparison of distribution of a continuous variable across multiple groups. So this visualization it highlights similarities between different groups. Like for example, we can import seaborn SSNS, then import in matplotlib, then import in pandas, and then we can enter a subdata, and then you can fetch histogram, value, frequency, title, and layout. Then is key elements, that is hue parameter which differentiates group for comparison. KT is equal to true with that is a value. Then multiple is equal to stack which adjusts the histogram, and then this method is ideal for visualizing and comparing distribution of continuous variable. Then how to perform binding based on predictive value. So binding based on predictive value it involves converting a continuous variable into categorical bins in a manner that enhances the predictive power of a model. So this technique is often referred to as predictive bindings or supervised binding, which helps us improve model interpretability and which can mitigate the influence by outliers. So it allows model to focus on underlying patterns in data rather than being influenced by extreme values. Like for example, we can import pandas as PD and we can perform all that binding based on predefined ranges. So overall summary is that paragraph with overlay it helps compare counts across multiple categories. Then contingency tables it shows the frequency of categorical combination. Histograms with overlay it is useful comparing distributions, and binding it converts continuous data into categorical bins. So these are the idiot so these are that some techniques which we can help to make such data to easier to interpret, visualize, and further analysis. Thank you.